Over to you, Professor Johnson.
Thanks so much, Chris. And I want to say hello to everybody from Toronto to Tokyo, from Shanghai to San Francisco, and from Cape Town to Berlin. It's a great honor and unusual circumstance to be able to talk to so many people from my office in Poquay, New York. It's just great. And I'm very excited to be here and to be invited. I'm going to take a moment to talk a little bit to get us all on the same ground to just say three things. The first thing is that nudges can be described by numbers. And I'll talk about three numbers today. But before I go ahead, the other thing I want to do is make sure we all agree on what we mean by a nudge. It gets used lots of different ways to talk about lots of different interventions. And I'm going to be pretty old school here and talk about what's actually in the nudge book, which is to say we're not changing incentives and we're not changing information. So for example, if you're selling insurance, we're not going to hide things from you and we're not going to change the prices. But we could change what Richard Thaler calls in Misbehaving singly irrelevant factors. So we could reframe them or we could make some more salient than others. That's sort of the key to what I'm going to call often choice architecture, to try and specify those kinds of changes as opposed to just simply nudges, which have a broad range of things. Okay, first, my three numbers, $456 per family. This is what choice architecture could save people if it's provided on the Obamacare health exchanges. Let me step back and say, health insurance is a really tough decision for people. It has lots of uncertainty. You don't know how much you're going to use. It has lots of unfamiliar terms. These are things like what a deductible is, what a copay is, what max payout is. In fact, if you take a look at one of the first exchanges run by the state of Massachusetts, it looked like this. And given the complexity of technology, I didn't animate this, but if I press a button to animate this and have it scroll, it takes 2 to 3 minutes. That's a lot of information for people to try and make the right decision. So when Obamacare was on the cusp, we were lucky enough to do some studies with people who were potential Obamacare buyers. Just for those of you who may not be familiar, these are people in the bottom third of the socioeconomic distribution in the US. It's the target market. And so we wanted to ask them, could they pick the right insurance policy? And think about this almost like a flight simulator. You know, in a flight simulator, you said, okay, here's the Boeing 737, go ahead and land it in Heathrow. And if you can do that, that's fine. If you can't do that, well, that's a crash. We gave people essentially a very simple version of the insurance decision, told them they were going to go to the doctor a certain number of times and see if they could find the cheapest policy. Now, what you see on the screen now is just one version of what we did. We got it down to be so simple. It was just literally 4 alternatives. We named them very cleverly A, B, C, and D here, and 3 prices: the monthly premium, the copay, and an annual deductible. And we wanted to see, could people do this task? Because after all, when people built choice into the health exchanges, they thought people would pick the right policy for them. Well, if this had been a flight simulator, it would have crashed. This is a little bit of a complex graph, but let me walk you through it. The red bar is how big a mistake they made. These people made on average over $500 errors in picking the right policy. That's $500 that could go to many other things like food, entertainment, cell phone. It's $500 that is essentially wasted. Same product being paid $500 too much for. The blue bar is fairly simple. It's essentially how well they did on this test, what percentage got the right policy, and here it was less than 50%, about 40% actually got the right policy. So we were pretty depressed, and we started asking, could anyone ever make this choice? And thinking about it, I realized that under my very nose were exactly the people who should be able to do it. These were Columbia Masters of Business Administration. After all, many of them had worked in consulting, they worked in financial services. They should be able to do it. And so we gave them the task, and lo and behold, they could. Their mistakes went down from over $500 to less than $100. And about 71% of them got the right policy. So we asked them, gee, how did you do it? And they said, well, Excel, duh. They basically copied and pasted our webpage, put it in Excel, and did the calculation. So this was a big clue to what people, ordinary people, weren't being able to do. So I have a lot of economist friends. Immediately they would say the following: well, that's nice, people screw up, but if you paid them enough money, they would actually get this right. So we went out and paid them enough money that they worked a third harder, in this. And in fact, this is what happened. Sorry, economists, it didn't make a difference. It basically showed no difference in getting it right or how big of an error they made. Now, remember, it's not information and it's not incentives. Well, maybe it's these seemingly irrelevant factors. So we took a lesson from our MBA students, said, how about if we actually just do the math of them? We, by the way, knew that our folks could do the math. They just were deciding not to. Big question, we cut the errors in half by simply doing the calculation, and they were now getting it right about 2/3 of the time. We also did the old classic, what I thank you for saying nice things about this, Chris, which is we changed the default. And in fact, that actually had a big effect too, almost the same size as the calculator. But what's interesting is when you combine the calculator with the default, you get an amazing thing happening. Essentially, the errors are smaller than the Columbia MBAs, and the percentage correct, they're doing at least as well. We basically, with the right choice architecture, turned ordinary people from the bottom third of the socioeconomic status in the US into people who could choose insurance as well as Columbia MBAs. So to come back to our $460, you could calculate how much each of these interventions improved decision-making. Incentives, only $30. The calculator and the defaults, about $300 each. But together, we saved each family, or if they were subsidized, the taxpayer, $456. If you actually multiply that by the number of people who made insurance decisions in the first year of Obamacare, you end up with a number that's about $9 billion. So number one, I think choice architecture has a huge effect on both economic and, because this is health and we know that health insurance helps, social welfare. So that's the first thing. Second number, 27.2. That is going to be the average effect of a default across domains. Let me step back a second and explain a little bit about that. As Chris so kindly mentioned, we'd done some work in the early 2000s looking at differences in organization agreement across countries. And this is the kind of famous graph that on the right that Chris talked about. Now, that's a nice poster child, but how typical is this? How much of a difference do behavioral interventions make in the real world? There's a nice paper done by Delavina and Linnos, where they actually look at all the interventions done by Behavioral Insights team and the American equivalent across a number of domains and analyze what was the average uptake, what was the average impact. You see big dramatic effects in my graph. Well, it turns out in the Behavioral Insights, the average intervention increased take-up by 1.4%, much more modest. In fact, if they looked also at academic papers, all the ones that people like myself have published, they found the average impact was 8.7%. There are two explanations for this. The first one, which I prefer, is that we're just better nudgers than the professional nudgers. It turns out they looked at that. The real answer is that basically academics seem to cherry pick. They publish the papers where the effects are large for good reason. We like to impress people with the points we're trying to make, but the real number is probably closer to the 1.4% in those studies. So chastised by this, we actually took a look at all the default effects that were ever published and studies that were not published. This is with John Yakimovitz, who's at Harvard now, Shannon Duncan, who's at Wharton, and somebody you'll hear about in a few minutes, Elke Weber. And we basically looked at all the papers and tried to see, is there a big effect of defaults? On average, there was. It's 27.4%. And so basically, it looks like defaults have a big effect. If I default option A or default option B, that's going to drive 27% of the choices for one or the other. That's a significant effect. But what's really interesting and worrisome is the effect varied. When you looked across all 58 studies, only 78% had significant default effects. That's 4 out of 5. 17% had no effect, not statistically significant. And 2 of the studies, or about 3%, backfired. This is really an interesting question and something that we talk about a little bit in the paper, but also I'm going to talk a little bit about in a forthcoming book. I'll plug that more thoroughly later. But Elke Weber will talk a little bit about this in a second when she talks in the 11th hour about part of this, which is query theory and how we assemble preferences. Okay, so I've convinced you, I think that defaults can have and choice architecture can have large effects. I think I've also convinced you that those effects really depend upon the context. The final thing I want to talk about is something very new and very exciting, and that's a question, which is who gets nudged? That is, are there people who are more susceptible for choice architecture interventions or nudges than others? And this is actually interesting. The answer is roughly, in some studies, 1.4 times more likely if you are lower socioeconomic status. To explain that, let me tell you a little story. We were lucky enough to come to data that was a long survey over 3 hours with 17,000 Americans about their consumer finances. We looked at this data to find people who were working, had retirement plans, and had been offered a default in their retirement plans by their employer. And we simply asked, did you take the default or not? So, interestingly enough, we found something quite nice. People who were in the bottom 25th percentile of socioeconomic status took the default 59% of the time. Those who were higher in SES took the default much less, 41% of the time. There's almost a 50% difference in default taking for the people who are poorer than the people who are richer. And just to give you a flavor of this, let me tell you a little bit about people in each of those categories. The 25th percentile people had started college but never finished. They didn't even have an associate's degree. They made about $39,000 a year for family income. People in the top 25%, at the top 25th percentile, had some postgraduate work. They actually had finished college and gone on at least to start degrees beyond that. And they had an average income for the family of $126. So $126,000. Important 3 zeros there. The thing that's important here is that notice that the default has a bigger effect on poorer people. And that's something I want to come back to, but that's just a story. Let me tell a little bit about some other studies we've done showing the same thing. Okay. One of the things we've done now is done a set of experiments where we try different kinds of nudges in different kinds of tasks. So we use lots of tasks, for example, financial decision-making, consumer decision-making. And we even looked at COVID protection. What would you do in this situation? Changing, for example, whether one choice was defaulted, whether we sorted the options from right to wrong, or whether we simplified the choice set, gave you 10 choices or 3. So we're doing this across a broad range of domains and a broad range of tasks. Let me just show you an example of one item, a couple items. You plan to go out to public to get groceries and are considering what to wear. You want to be safe while following the recommendations from the CDC and other experts. Do you, and people had 3 choices here, wear an N95 respirator, wear a homemade cloth face mask, or not wear a mask? And obviously, the right answer is the second one, which is italicized here, wear a homemade cloth mask. So what we did was essentially either make that the default or not, and see if that made a difference in people's choices of protection. In financial decisions, we did very similar things. Imagine you have debt on 2 credit cards at the same bank, have money that you would like to use to pay off the debt. Both cards have balances of more than $500. One card has interest rate that is twice as high as the other. We try to make these not simple math problems, but logic problems at best. And you could either pay off the $500 on the higher interest card, pay off $250 on both, or pay off $500 on the lower interest card. Again, we could change what the default was. The picture which emerges after all these studies is quite simple. It is that, again, people who are lower in socioeconomic status are more likely to be affected by nudges. This graph's a little bit complicated, but just look on this axis, on the bottom axis. Right is on the rich, poor is on the left. Or the right are rich, poor are left. And what you see are 3 lines. The top line is pretty simple. That's people who've had the good default. The bottom 2 lines are the neutral default and the bad default. What you see is, okay, for the very rich people, defaults don't make a difference. But for the poor, they make a very big difference. In fact, you make people pretty well off in their decisions if you give them the good default, but they do badly if you give them no default or the bad default. Now, this is kind of important, and we asked, what causes this? One thing is we looked for fluid intelligence. So we gave people tests that are standardized measures of how fast you think, no effect on default taking. We looked at lack of effort. That is, did people actually work hard? This is on the web, so we actually measure how long they look at the item. That does not affect whether or not they take the default. We looked at personality, conscientiousness, agreeableness, a scale called need for cognition. All those things had no effect on default taking. We even used incentives. We paid people to get the right answer. That did not have an effect on whether or not they paid attention to the default. The answer is not surprisingly are two things that we know a lot about. One is numeracy, and that essentially is how well and comfortable you are with thinking about numbers. And the other is domain knowledge. So for financial decisions, this would be financial literacy. For health, it's health literacy. Now, this seems sort of obvious, but the default point is really important. It takes a lot of work to get people to be more numerate or to teach them the domain knowledge. Changing default is easy. Literally, if you look at the HTML code, it's changing one line of code. And we can get people to do much better by changing the default than we can by trying to teach them, or at least as well as trying to teach them. This is important because it has, and I'm going to close in a couple of seconds, the kind of really nice result, which is this. That basically, I'm sorry, let me go back one more, which is this, that nudges can reduce disparities. That actually people who are disadvantaged because of background, because of lack of numeracy or lack of domain knowledge can be helped significantly by using the right choice architecture. And remember, it's not just about defaults. We've done this with sorting. We've done this as well with the number of options. So actually a very inexpensive way of doing interventions to improve decision-making that is particularly effective is to change the choice architecture. Okay, let me summarize by sort of reviewing the three numbers I talked about. First is I want to talk about two metrics we've talked about. One is dollar value. When you change choice architecture, you can save people in health insurance a lot of money, significant amounts of money. And that I would argue that ignoring choice architecture is actually not just a mistake, but one that is a costly mistake. We also then talked about a second metric, which is effect sizes, and showed that effect sizes vary across different kinds of choice architecture interventions or different kinds of nudges. And that moreover, they're very variable across studies, and that we need a theory, I think, for how choice architecture and nudging works. And so here's my unabashed plug. A book, Design Decisions, will be coming out next fall of 2021, Riverhead Books. It's where I developed that. Again, Elko Weber will talk a little bit about at least one part of that theory. Okay, one factor that accounts for this variability is people different susceptibility. Low SES people show larger effects of choice architecture. This is actually important. It has good news. Nudges can diminish disparities, but there's really very serious bad news here. People in previous talks have used the term sludge for bad choice architecture, bad nudges. Well, sludge hurts the poor more. If you recall that graph, basically, it actually hurt them more than providing no default at all. So that, I think, is a very important takeaway. The field is now 12 years old since Nudge, the book, came out. And I think it's doing very well. It's a tweener, but it's doing pretty well and actually has a lot of potential. I'll close by thanking all the funders, National Science Foundation, Russell Sage, and Alfred P. Sloan Foundation. And I won't name all my marvelous co-authors on the work, but I will point out this is Kellen. It's not his precocious daughter. So closing on that, I will turn it back to Chris. Thank you very much.
Eric, thank you. Listen, this is a little eye-opening because I think that most people look at nudges as either beneficial or benign or benignly ineffective, meaning there's no negative. So the idea that on the one hand, nudges can discriminate unintentionally and have a differential in terms of class or knowledge, domain knowledge or income and demographics. And on the other, that they're not just neutral, that if we're not careful, we could convert a nudge for the underprivileged into sludge, if we've got that right. Could you give us an example that you might see out there, either existing or one you worry about, to make this idea concrete for us?
So one of my favorite bad nudges is when I try and unspam myself. If I'm getting spam, they're required by law to have an unsubscribe. I'm seeing lots of links today where the unsubscribe link is there. It's just in light gray and a dark gray background in very tiny 8-point font. Okay, that's meant, I have an opinion. I want to get rid of this spam, and they make it very hard for me to exercise that. Now, if you think about consumer finance, I think the more complex the contract, the harder it is for people to understand. That, in fact, suggests to me a very important implication, which is that the poor actually are ending up having less good decisions in that choice architecture could help, but is being potentially exploited by some kinds of firms.
When you look at those in the lower social economic status, one of the questions coming across from Slido is could it be that people with lower SES usually have scarcity of time and resources in the rest of their life, and hence makes decision-making that much more difficult?
The answer is yes. Those things would make the situation worse outside of our experiments. But one of the nice things about doing experiments is you can control that. And actually, we pay people. So they're actually, by taking the wrong default, losing money. So it's actually costing them. The nice thing about the bad thing about experiments is they're outside of many of these real world effects. The good thing about experiments is they're outside many of these world effects. So I think we can tease those apart.
And you mentioned that you looked at many of the cognitive styles and personality big five, and basically that did not explain the difference in these. Somebody on Slido asked, beyond need for cognition, they asked need for cognitive closure. That is, for those who are not familiar with the jargon, some people need more certainty in their lives than others, and they're more uncomfortable with uncertainty. They have uncertainty avoidance. So this question was, is there anything that might mediate?
Maybe. We haven't gotten around to trying that yet. And the nice thing is all of our paradigm, our data is all on open science frameworks. So you can actually do the experiments and manipulate anything and measure anything you want to see if you can influence that. We will continue to explore these issues. We're very interested, for example, on people's time preferences. The people who are impatient, are they more likely to use choice architecture shortcuts? Don't have the goods yet, but there's lots of work to be done.
Eric Johnson of Columbia University, thank you so much. We look forward to your book. Thanks so much for making the time for Nudgestock.
Thanks,
Now, everyone,
it was a real pleasure.
Pleasure is ours.